Welcome to this course, Machine Learning for All. Now we are in the module 2 and topic 5. So here actually we will do kind of a demonstration of how these two algorithms basically, one is your simple linear regression or your k-means based regression. Then you have two another classification models like logistic regression and k-nearest neighbor. We will be implementing with the help of Python. And further, we will try to understand or implement the decision tree models with the help of same Python. Python. Not only we will solve one regression problem, also we will be solving one classification type of problem. In this topic, we will be understanding mostly how to use Python for solving regression type of problem and also a classification type of problem, and also you will get a kind of a hands-on experience how the troubleshooting or how the result can be interpreted with the help of Python. Okay, so before proceeding, here I'm just renaming this Google Colab file. Actually, the name of the file is, I'm just giving it a regression. So just remember that we are dealing with that Bollywood success data. So where we are trying to predict the value of a box office collection. So in that case, first we will just define or we will just call all the libraries actually required to run the particular code. So here in this platform, just every row you can just write separate code. So first row, I'm just defining all the libraries which are required for the coding. So libraries, call the libraries, call the for implementing data manipulation and regression. Now the basic library that you need to install first is pandas. So I can consider it as import pandas as PD. So how you can make sure that whether you wrote right or wrong? So if you just hit that button, the play button, you will find quickly whether your code is right or wrong. Because it is a online platform, so you have to give little bit time, and again the pop-up is coming that it's taking long time to complete the process. So here you can see if some kind of a error you have error occurred in the code, so it will show the invalid syntax. So here the spelling is mistakes. See, import. So if I just correct it and run it, so it is right. So next I need a NumPy. So when I'm writing this code, see automatically it is giving some kind of suggestion. So what are the things I need for coding? And as per your requirement, you can just tab it to check, or you can just type it. So every time if you have any kind of a doubt, so you just click on the hit run button and just check whether you wrote right or wrong. So in this case we have rightly typed our required library name. So now what is the pandas? Pandas is a library where basically it is useful for playing with the numbers. Basically you can manipulate or you can define some kind of a data frame with this, or you can manipulate some column, rows. So all kind of data handling can be done through this pandas. Okay, then you have a NumPy. NumPy also, it is similar to pandas only. Here we can do some kind of numerical operations, which is nothing but used for manipulating the data columns. And next is matplotlib. This is basically used for plotting any kind of a diagram. Let's say in this case maybe we are plotting that original versus predicted value. So in that case we need this library. Next we have the main libraries, that is your regression model, or if you need kind of matrices which will help you to measure the impact or the performance of the model. So those things need to be called over here. So in that case I have to just write from sklearn. So it's already showing the suggestion sklearn dot linear underscore model import linear and again I'm just making this mistake, typos error. And then enter from sklearn dot model underscore select selection import train test split. And again you have to bring the model matrices. See, it already giving me kind of a suggestion to bring all these libraries. So this is kind of a very much helpful for the new coders who are just recently started coding in Python. It will very much help you. Now let me just tell you why I need all these libraries. First let us just start from the from sklearn dot linear underscore model import linear regression. So here basically I'm just calling this linear regression function to perform any kind of training which will help me to generate the linear regression. The next one is model selector. This will help you to divide the data into two halves, that is training and testing data. And last one is that matrix which are required to test my model or measure the performance of my model. So here I just took the mean squared error and R square value, so coefficient of determination. So you can easily calculate the root mean square by taking the square root of this mean square error and just summing all the value. So basically this mean square error is nothing but it just find out the deviation from the original value and just find out the average value of that. If you just take the square root of this, so definitely the RMSE value you can easily calculate out of it. So once we define all our necessary libraries, so this is fine. So I'm going to the next. So here you have two options. Let's say if you want to create a section in the code, so if you just hit on the text, so here with the hash, if you just write that define data frame, then you will find in the section it will show, and how it will show that particular section name. So if you want to increase the size, if you put another hash, so it will just increase the size. And here also you can modify, you can add description of the section. Let's say here I'm just writing in this section data frame is created from the Bollywood success data set. So this is kind of you are adding some kind of description to that particular data. Then you can go for the again another line of code you can generate. So here actually we will try to call the data. So before that you just check whether your drive is mounted or not, because in the drive you have to upload the data prior coding. So here already if I just open the drive, so it is taking little bit time because of the internet speed. So once it is opened, you will find that particular data set is already provided or already uploaded in the particular folder that I already created as machine learning for all. So let me just open it. It is just taking time. So how to now define the data? So in that case, I'm just or data frame. So here actually you need the help of pandas. So if I write df, so basically this is the name of the particular data frame. Data frame is equal to pd dot read underscore. You can find that there is an option CSV or Excel. It is here. It's showing CSV. Now in our case, our data is in Excel. So later you will find, because this is kind of a generated suggestion, but you can use this. But the thing is that our data is not in CSV, our data is in XLS. So in that case, you have to just use this Excel EXCEL, and within the bracket you have to just put the path of the data. So now if I click on this, again it is taking time. Okay, the folder is now currently available. So I will just try to find out where is the machine learning for all folder. So this is the folder where I actually stored my data. So if I just click on this 3 dots, here is the copy path. So if I select and put this over here, so you will find that data is actually an Excel file. So if I hit button, so I can easily find that the particular data is now available in that data frame df. Now next section, I want to just check what are the variables are available inside my data. So again, I'm just creating a code. So here I'm just putting the note, check the variables inside the data. So in that case, what I will write df, or here my data frame name is df. So data df dot info. So this will, if I just display this, display, see, here you will see all the variables names or the features name, and the number of data points are available with me, and the type of data we are dealing with. So this is kind of a very much helpful to know what type of data or what category of data I'm just dealing with in my data set. So now next I am going to define my variables or features, input feature and output feature. So already in our Excel demo, we found that we use this views, YouTube view, that film budget, YouTube views, YouTube likes and dislikes as the input feature, and this box office collection as output feature. So that same thing we will be defining over here for implementation or greater and or understanding of the model. So here straight away I can just write hash define the input and output variables. So what I will do, first I will define a variable or a particular list where I will just put all the values. So here I'm just writing df. Within that I will just put within budget. So it is already showing me suggestion, then comma, views, comma, likes, then comma, dislikes. And my dependent variable or output variable is df equal to boc. So if I hit OK button, so it is showing error because it cannot handle this many variables. So what I have to do, I have to define a list which is indicating the names of these variables. So in place of x, I just write, let me just write features or predictors or input variables equal to, or input var, it is better, and then I just put the names of this variable. So now let me check whether there is any error. Okay, right now what I will do, x equal to df, and within the bracket you have to just write input var. So this will properly define that particular variable set which will be used for our modeling part. Now let's say here also I'm just adding one text, initiate the modeling, initiate the modeling by defining the training and testing data. And training testing data. So this side, actually this portion, we will split our data into two halves, that is training and testing. So for that you have to first define the different types of data that is required for your trainings and testing. So in that case what we will do, for training also we can generate separate variable list, let's say x training, x testing, and for y also y training and y testing. So we will consider as x underscore train, comma, x underscore test. Similarly y underscore train, comma, y underscore test, and this variable will be generated with train underscore test underscore split. Within bracket you have to just mention, see here also you can get little bit of indication what are the things that you have to write, because it shows you automatic suggestion. So which array you want to use. So basically array is our x and y. Then test size, so basically you have to write test underscore size equal to 0.3, because 30% of the data is used for testing and 70% of the data will be used for training the model. Okay, then you have to just mention random state equal to 42. So this 42 is nothing but it will make sure that if you are training again with same state number, it will generate similar kind of result. And if you just hit on this, so again some kind of error is generated. So what are the errors? Let me just check. Got an unexpected keyword argument random. So here again I just missed R. So if I put R, so it will random. Okay, E is there. So this is the typo error. Okay, random state. So again the code is running. Now after that you have to train the model. So here I'm just writing again, creating another code. Here I'm just creating a note, train the model. So how to train the models? First of all, you have to just give a name to this particular model. So let's say in this case I'm just writing Bollywood success BS underscore linear regression. That is my model name, and here I'm just writing that same function name. You have to just write linear regression and the function. Then you have to just write how you want to generate the model. So in that case BS underscore LR dot fit, within bracket you have to just mention the training data set, that is your X underscore train and Y underscore train. And if you just hit on the, so your model is now built or it is trained. Now what you have to do, now you have to just test your model. So here let's say I'm just creating another text, testing your model. This section is dealing with the testing part of your model. So here it will, now you have to create an array which will store the predicted value. So I am here, I'm just writing Y underscore pred. So you can see that straight away it is again suggesting me how to go for the prediction. So BS underscore LR, so basically you are just putting the model name, then predict. This is also keyword. Within the comma you have to just write the X test. So if you just hit enter button, so all the values are now within the Y predict. Now once you have tested your data, so you want to compare the two values, right? So in that case what you do, you just try to plot them. So here I'm just plotting these two values side by side, so it will help us to find out how much accurate. So here I'm just writing hash plot the Y underscore pred and Y test. So in this case plot PLT, so basically we will use a scatter plot. So PLT dot CATT scatter, and remember this Y test comma Y pred. After that you have to just put some levels, right? So in that case you have to mention that what is the level in the x-axis and y-axis.